Hi all, welcome to the machine learning course. Today I am going to take the topic on the non-linear support vector machine. Okay, we are aware of it, what is linear SVM and non-linear SVM in the previous video. If we are able to classify the data points using a straight line means that is a linear support vector machine. If we cannot able to plot differentiate using the straight line means all the remaining points are considered as a non-linear SVM. Okay, so these are the data points that they have given, 8 samples they have given. Out of the 8 samples, 4 samples are positively labeled and 4 samples are negatively labeled. Okay, here we have plot this graph here. Okay, this red color is marked as negative samples and the blue color is marked as positive samples here. Okay, see here we cannot able to differentiate the data points using any straight line. Whether you can able to draw the straight line here. Okay, you can draw the straight line here, but you cannot able to differentiate the data points. Whether you can draw the straight line, if you are able to draw the straight line here also, you cannot able to differentiate the data points. So it comes under the non-linear type. Okay, so we are going to solve this problem. For solving this one, this is the formula. Okay, so pi of x1 comma x2 is equal to this is the formula. Okay, so if the square root of x1 plus x2 square is greater than 2 means we have to go for this formula, or else we have to retain the same value as it is. Okay, so if it is greater than 2 means we have to apply this formula and getting the respective value, one value here and one value here. Okay, then we are calling here as x1 and here as a x2 value. Okay, so we will consider the first the positive examples. So these are the positive examples. If you are applying on this formula, all the values are greater than 2. So what we have to do is we have to apply this formula. Okay, so I directly apply on this formula and get these values. Okay, so 2, 2, 10, 6, 6, 6 and 16 are the value that we get it. Okay, and the next sample is the remaining 4 negative samples. Okay, so if you are applying here, we will not get more, greater than 2. Okay, so we have to go for otherwise options. So here we have to retain the x1 and x2 value as same as the previous one. So we are keeping the same value as the original value. Okay. Now we have to consider we are drawing this new data points here. Okay, this is the new value that we got it, right? So this is the new value that we got it. Okay, and old values are retaining here. Okay, so these are the old values that are retaining here, and these blue points are the 4 new values that we got it. Okay, now we are going to draw the hyperplane here. Okay, we have to, as like the linear support vector machine, here also we have to identify the nearer points. Okay, so these two are the nearer points. Okay, anyhow we have to consider at least one positive sample and at least one negative sample. Okay, here one positive sample and one negative sample. So S1 is equal to 1, 1 and S2 is equal to 2, 2. These are the 2 points that we are considering. Okay, and we have to augment with bias value. The default bias value is 1. So we are converting this normal support vector into the S1 cap, that is 1, 1, 1. We have added this bias value here in both S1 and S2. So it becomes S1 vector and S2 vector. Okay, and we have to apply the formula here. Okay, so when we have considered the negative sample, one negative sample, so we are applying the value as -1 here and one positive sample, so +1 here, and this is the formula for finding this alpha 1 and alpha 2 value. Okay, we have to replace the S1 vector and S2 vector value here and solve this problem. You will get these steps. Okay, 3 alpha 1 plus 5 alpha 2 is equal to -1. 5 alpha 1 plus 9 alpha 2 is equal to +1. Okay, this is the value that we get it. If you are solving this, you will get alpha 1 is equal to -7 and alpha 2 is equal to 4. Okay, after that we have to calculate the weight vector. Okay, so this is the formula for applying this weight vector. So alpha I SI vector. So alpha 1 S1 plus alpha 2 S2. So we are replacing this alpha value and S1 vector value here and finally getting these value as X, Y and W. Okay, now we have to draw the hyperplane here. Okay, so the formula for drawing the hyperplane is W is equal to Yx plus B. Okay, so this point belongs to X and this points belong to Y, and this is called bias value. Okay, as like previously I said, if 1 0 means the line is parallel to y axis, x value 1 and y value 0 means the line is parallel to y axis, and 0 1 means x value is 0 and y value is 1 means the line is parallel to x axis. If both the values are 1 means the line is, we have to draw the line at 45 degree Celsius, 45 degree. Okay. So, this is the value that we are drawing it. Okay. So, the bias value is 3 here, note it carefully here. This is the bias value 3. So, we have to draw the hyperplane here. Okay. So, this is the hyperplane, we have to draw at 45 degree because the value here is 1 1. If it is 1 1 means we have to draw at the 45 degree. So, 45 degree means this is the 45 degree. So, we are drawing the hyperplane here and these two are the support vectors. Okay. So, similarly we have to calculate it for the mining problem. Okay. Thank you for watching.